Hello and welcome to Microsoft Hates Greg. My name is Greg Deckler, and today we're going to be revisiting the concept of a rolling date diff, which is the subject of our last video. So why are we revisiting this topic? Well, not gonna lie, I've been slightly obsessed with this topic for the last couple of days now, um, we're revisiting them and making a bunch of improvements to it. So the last versions that I had, I think they were a little scuff. I mean, most of my DAX is a little scuff, but maybe this was more scuff than usual, and they weren't very consistent. They were like it was the same concept, but like three wildly, kind of different approaches to a certain degree. Um, and then I didn't include a weak version, right? That was one problem. The other one is that it didn't cover, it only covered positive differences. Like in date diff, not originally, but when they fixed it, you could you could put in if the first number was bigger than the second number, you got a positive number. If it was reversed, then you get a negative number, right? And then I hadn't covered time. So the hour, the minute, and the second variants, which kind of get interesting. So stick around until when I cover those, because it's kind of, you'd think it'd be easy, kind of like with days, right? You just subtract them. But it's a little, there's a twist. So let's go ahead and get into it. And I'm going to cover and the nice thing about this new version is they all look kind of very much the same. So I'm going to cover probably the month one in most detail, and probably maybe quarter. And year and month are very similar, and quarter and week are very similar. So here's the original DAX. Um, I have no idea why underscore date and underscore today, it doesn't recognize them, other than IntelliSense and DAX sucks sometimes. But anyway, this is the original one. So you can see, I was using like a year month kind of thing. I've used that trick in the past for various different things. Um, and then, if the day is less than the day, I don't know, it's kind of scuff. I kind of liked the version I ended up with within my quarter, when I recreated the quarter one, where I actually used the date. So I was like, okay, but maybe I can take that pattern and apply it to everything. And so that's what I did. And so first thing though we need to do is we need to account for, where, because if we use a generate series from, a lesser date to a larger date with an increment of one, then that's not going to fly, right? I mean, we're not going to get any table back, or maybe just one value. It's not going to work right, right? So first thing we need to do is account for that, whether date one is larger or smaller than date two. And so the way we can do that is the min date variable right there. So maybe you're not familiar with this version of min, because usually you're just taking min of a column in a table. But min also has the ability to take a second parameter, and it'll actually return the lesser of the two values. So basically, we're figuring out what our min date is by comparing date one and date two, right? And we're doing the same thing with the max function, figuring out the max date one and date two. So then we can figure out our multiplier. Now we're going to use this later. So we're just going to set it to -1 or 1, which is basically, if date 1 is less than date 2, then we're going to end up with a negative number at the end, just like in date diff, right? So then our years, we generate our series from our min date to our max date, increments of 1 at the year of those values. We generate our series, and I changed this, instead of hard coding 1 through 12, generate a series between 1 and 12, increments of 1. We cross join those two together, get the Cartesian product, right? We add our column now, and this column is a date column. So we're doing date of our year column, our month column, and our day of date one, because date one, the first parameter, is always what we're kind of comparing to, right? So now we have an actual date, just like we did we ended up with in the quarter version of this in the last video. So now we can just filter the table between, min date and max date. We can count the rows. And then this last piece right here is, so if the multiplier is greater than 0, it means we have working with a positive number here. Then we do a pre-result, we subtract 1 from our count. And the reason is because we want to get a 0 if we're in the current month. Okay, so just like date diff, if you're in June 2024 and you want to comparing it to another date in June 2024, and it's a month, it's going to return 0, right? If it's in the same year, same month. So we want to emulate that behavior. But otherwise, we're at least going to have one row in our table, at least, the current year. So we have to subtract 1 to get it to 0 out to the, so it starts from 0. And otherwise, we take our pre-reserve count and we multiply it by multiplier. We don't have to subtract or add anything in that case. And so you can see here, and this it ends up being a little different than like the rolling month, the kind of our easy rolling month, which was this one, where we just just figured out whether the day was less than today, etc. In that case, because the comparisons we're doing, I was adding one versus whatever. But so anyway, so let's take a look at this real quick. So and now I hard coded today in these formulas to be June 6th, right? Just so that I could, if I was playing this with this tomorrow, I'd get the same results and all of that sort of thing. So yeah, here we go. So June 6th, obviously we should get 0, right? So we get 0. Now any date after June 6, 2024 in a rolling date diff scenario, any date, in the next, 30 days or whatever it is until basically 7/6/2024 is going to get a -1 because it's -1 month in the future, right? Or it's 2 months in the future, or 3 months in the future, right? It's just the rolling scenario, that's anything past the current date is going to be it's at least going to be -1. And I think that makes a good amount of sense. But as you can see, so May 14th, so that we should get a 0 all the way up until May 4th, 2024, May 6th, 2024. After that, we should get 1, and 5, 5, 11, 12, 17, 17. So you can see the numbers are a little different than kind of the naive version of rolling month date diff. But I've checked these all out, and these all seem correct. And same here, right? It's, all the way up until July 6th, we should be getting -1. So this one right here, August up to August 6th will be -2, and then past August 6th will be -3, all the way till September 6th, right? So this all checks out. So now year is then very similar to this. So year, so you can notice that these are all these have a very similar pattern to them now. And I'm not doing a bunch of switch true and like crazy logic and stuff like that. Especially this one changed probably the most. So again, same pattern, right? I grab my min date, my max date. I figure out my multiplier. I do my years, same exact code. I don't have to do any cross join in this case. So all I have to do is add a column where the date is the month, or the date is the year column. The month is the month of the date 1. The day is the day of date 1. And then all I have to do, because then again, that figures out that is 1 rolling year back, or 2 rolling years back, or 1 rolling year forward, or 2 rolling years forward, however it happens to be, based upon the day and the month. I can then do the same filter, right? I can count the rows. If the same logic, right? If the multiplier is greater than 0, subtract 1. Otherwise, multiply the result, the count by the multiplier to get my negative. And you can see again, this is to hell with date diff year, right? Same kind of concept. Any date past today is going to get a -1, and that's going to continue all the way up until June 6th of 2025, after which it's going to go to -2. This number right here is going to go back all the way until June 6th, 2023 will be 0 based, and then anything past that within the next 365 days or so is going to be a 1. So there you go. Now the quarter one actually remained fairly much the same. It changed somewhat. But as you can see here, this is the original quarter version of the formula. And this is the improved version, where again, I'm figuring out my min and max date, figuring out my multiplier. I do the same concept. I change the hard coding of 1, 2, 3, 4 to generate series. So I get my years, get my quarters. I cross join them together. In this case, I'm still going with the previous logic of, because really what I'm trying to do here is get how many quarters I need, okay? How many quarters, because what I really end up needing to have is a table of all the quarters, a reasonable maximum, which I'm trying to figure out dynamically versus kind of hard coding it, a reasonable maximum of the number of quarters, because I need that index, that 1, 2, 3, 4, 5, 6, 7, 8, right? And I can't really get there until I figure out how many quarters approximately I need. So that remained pretty much the same. So I do my rolling quarters table. Now, the part that changed in this is I still generate a series from one to count, but my var, my EO month, end of month variable changes because I have to take into account whether it's forward in time or backwards in time now. So what I do is, it takes the quarter is 3 months times my index value, right? Times my multiplier times -1. And this is just to flip the sign on it so that positive numbers come out negative because I'm going back in time. And yeah, positive negative values come out negative, or because I'm going forward or sorry, I got that messed up. If I'm going back in time, that thing needs to be negative. If I'm going forward in time, it needs to be positive. There you go. So then I can still do the same filter, the same count rows, and very similar result. That's a little different. The multiplier is positive. In this case, I can just return my pre-result. If it's negative, then I have to do a pre-result plus 1 and times my multiplier to make it negative. So it came out a little different in that case. And now I'm starting to question whether or not this that is correct, but we're gonna check the numbers here. So the quarter for 6, so again, everything forward in time is at least going to be -1, right? I think that's why I needed to have that +1 in there. +1, because those were coming out to be 0. And anything positive, anything past today should immediately get -1. And that should continue on in this case 3 months into the future, which would be 9/6/2024. And you can see that my 8/14 through 6/14 all come out -1. And if you do the math on this one comes out negative, should come out -4, should come out -5. In this case, if I'm going backwards in time, right, then 3/6/2024 should be my cutoff point for 0. And you can see that this is 0 still in May, but and then 12/6/2024 should be 1. And you can see here, January 1st and December 31st are 1, and so on and so on and so on. Okay, and then week ends up coming out almost identical to quarter. So same exact code. What really changes here is my second generate series is 153, increments of 1 versus 1 to 4. I'm still cross-joining that. I'm still multiplying year times 100. In this case, I just add week, and then I'm using week num instead of quarter, right? So very, very similar in terms I don't have to figure out my end of month. I can just use my 7 times my value times my multiplier times -1 when I'm adding my column to my rolling weeks table. But very similar code. This makes me happy, right? In this case, I really have kind of 2 patterns involved. One, I can get to a date very quickly within my table that I'm going to filter. The other one, really the only additional logic for weeks and for quarters is I have to figure out a reasonable maximum somehow dynamically to figure out, yeah, this is how many I need in this table in order to get to a result. And again, if you go through the logic here, it all works, right? So yeah, this becomes 6/2 because 7 days after is 6/13, that would be, so 6/7 to 6/13 would be -1. And then you get to -2 once you get into the 14th, right? So that's why this is -2 weeks. And the same here. So I'm on 6/6, and I want to go back 7 days. That's going to end up being May 30th. So this falls into the 0 camp. So yeah, it all works as far as everything I've tasted. Tasted? No, can't eat this stuff, Greg. Everything I've tested, this all works perfectly fine. And I think this is into a decent enough shape where I could probably publish this out to the community site, to the quick measures gallery. But let's take a look at one last thing here, and that is the time stuff, because this stuff gets interesting. So date diff hour, right? Date diff hour, I created a different table here, and this table, has these times in it, and I initially generated them randomly, then I copied the table over and kind of made it static because I didn't want them changing all the time. So date diff hour, you can see this is the number it comes back. This is what it comes back with. And date diff hour is very similar. Just use hour at the end, right? Instead of month or day or whatever else you want to use. So to recreate that though, and of course I've got this in a state where I was messing around with it, but I created this function right here. And then let's go ahead and switch this. Give me a second here. I've got a step ahead of myself. Okay, so we create a base, which is basically we're just subtracting numbers times -1, make sure it comes out a number. Now there's, that will come out with essentially a number of days, which will be the integer portion, and then the decimal portion will be fractions of a day. So we should just be able to multiply that number by 24 and get a result, you would think. So you're saying, well, what's this extra if hours is greater than 0, round up, otherwise trunk? Well, let me show you. So if I were to change this to hours, you'll see that I get 117 hours here, but 116.39 hours here. Where's that coming from? Well, and where's this 117 coming from, right? So 6/6 to 6/1 is 5 days. And I'm just going to show you, and I don't know how date diff, I think it's the second version I'm going to show you guys in terms of how this gets calculated, but let's go with one version, right? So if it's 5 days, right, times 24, ends up being 120 hours. So 24 hours a day, 5 days, 120. Now, but where we have to subtract, but that would take us back to 6/1 at midnight. Okay, so we have to subtract out 3 hours because it's 3 a.m. So -3, there's our 117, right? Now, but I don't think that's how date diff is working. So how might date diff be working? Well, if we take and put our base in here, we get 4.85 days. Okay, so if we take 4 days times 24, we get 96. Now, if we take 0.85 days and times 24, we get 20.4. Okay, so if we take, so that's where that's where that number is coming from. So if we take 96 plus 20, we're going to get 116. And you can notice that if we actually put hours back in here, yeah, so all of these numbers are one under. And I think this has something to do with the being zero-based as midnight's zero-based, or who knows exactly. But I think it's, we're basically what I just showed there. It's 20 hours in, but we're 0.4 into the next hour. And the subtraction and addition doesn't really handle that unless you're doing some rounding up or truncating, etc. So you notice that all of these are, 211, 211, 113.49, 1657, et cetera, et cetera, et cetera. Right. So these we just have to trunk off the extra minutes, more or less, the extra partial part of an hour. Whereas when it's positive, we have to account for that partial hour that we've rolled into the next hour, if you will. So, and if we do that, we round up to 0 digits in that, we get the right answer for date diff. So this completely replaces date diff hour. And now the other ones are very similar, right? So if I do date diff minute, it's the same basic concept. Otherwise, I'm multiplying 24 times 60, and then I do my round up or my truncation, and I get the same results for minutes, right? 818, 448, 828, 274, 707, 998, right? 466, et cetera, et cetera. That's all good. Now, seconds. This is where it gets a little interesting. So if I do a base, do the same subtraction, now I'm multiplying 24 hours times 60 minutes times 60 seconds. Same thing where I'm rounding up or truncating. This is where things get a little odd in that some of these are off. Okay, so 077, 866, 669, 433, 740, 495, 850, 851, 046, 047. right? And it's the same down here, right? 662, 467, 915 versus 916. 006 versus, so some of these are just a little off. They're just one off. And what I believe is going on here is rounding. Because if I do something like this, round this to, let's say, 5 digits, all of a sudden, all my discrepancies go away between date diff. And so date diff internally, it looks like does some rounding of the numbers that are actually coming back. Because these numbers can go out. Like if it's, I did this rounding at like 10 digits, I believe that's where it starts to stray. Yep, you can see it. 850, 851, 046. 047. So I don't know where date diff rounds exactly when it's doing its calculations, but it's rounding somewhere. Whether that matters or not, whether you're a second off versus if you go to 10 digits of precision versus 5, and that matters to you, I can't imagine it would. But if it does, just have a note that date diff apparently rounds. All right. Well, that's all I had for this video. I hope you enjoyed it. Now I can stop obsessing over this topic. And anyway, hope you enjoyed it and see you next time.